Hi, welcome to 9-1, part 2. I'm on page 482 if you want to follow along. This concept is going to be super important for you for all your future math classes. You're going to see it a lot in Algebra 2, and it's just an introduction for this part, so don't worry if it seems a little confusing. You'll still get lots of practice on it. It's called rationalizing the denominator. And what rationalizing the denominator means is that you are not allowed to have a radical sign in the denominator of any fraction. So what we're going to do is we're going to quote unquote get rid of it. And the way that we get rid of it is we are going to multiply it by 1. Okay, we're going to multiply it by 1, but it's going to be in a special form. The form that it's going to be is going to be the square root of 3n over the square root of 3n, because that's 1. Now let's multiply across. This becomes a square root of 15n over, now the square root of 3n times the square root of 3n, since you see it twice, is really the square root, of 9 times the square root of n squared. And when we simplify that, this stays the same. It comes out to be the square root of 9 we know is 3, and the square root of n squared we know is n. And that's a 15. So really, you're going to get used to is that when you multiply a square root by itself, it gets rid of the square root sign. Okay, and this is my middle step here, so you can see why it gets rid of the square root sign. Now I want to point out that this is inside the square root sign, so you cannot simplify these two things, nor can you simplify the n's. So please do not do that. Now, if you remember, the square root of 16 is really 4. So that means the square root of 15 is like 3 point something. So this 3 here is a whole number, and it means that you cannot cancel them out, okay? So when it's stuck inside the square root sign, make sure you know that you cannot simplify with something that's on the denominator, okay? Same thing with these n. So this is my final answer. All right, let's go to example B. So it's 2 over the cube root of 9. Okay, this one gets to be a little tricky because it's now a cube root. And you now have to think about what are your perfect cubes, right? So my very first, I'll write it on the side, my very first perfect cube, and if you remember, 1 times 1 times 1, that's a cube, right? The next one is going to be 2. 2 times 2 times 2 is going to be 8. Next one's going to be 3 times 3 times 3, which is going to be 27. Okay, so these right here are perfect cubes because you have to multiply a number 3 times to get that number. Okay, so let's look at this one. Don't think that the answer is 3 because that's a square root. This is a cube root. So now we have to think. For square roots, it's easy because you automatically multiply it by 1 in the form of the denominator. But for cube roots, you have to think a little bit. You have to think, what is the closest cube root to 9? Well, it wouldn't be 8 because that's too small. Oh, can we turn 9 into 27? Yes, we can. So we're going to force it to be a cube root. I'm going to multiply the bottom. I'm going to force this to be 27. And how do I do that? I multiply it by the cube root of 3. It has to be a cube root. Okay, the roots have to be the same. So this is all brand new stuff. I know it's hard. We'll have lots of practice on it. So now let's multiply it across. This is now going to be 2 times the cube root of 3 all over the cube root of 9 times 3, which is 27. Well, I just showed you over here on the side that the cube root of 27 is 3. So that gets rid of the square of the radical sign on the denominator. And this is going to be your final answer. And even though I know you want to cross out these 3's right here, you know not to, because this 3 is stuck inside the square root sign and you cannot simplify it. Okay? Next example is brand new to you, and again, you're going to see it in Algebra 2. This is just an introduction. Sometimes I don't even get to it in Algebra 1. So this is called a conjugate. And a conjugate is a binomial where it has a square root in it. Okay, so this is actually one entire term. I don't want you to think of it as two. It's two terms, but it's stuck together, which means that it's a binomial and you can't separate it. But again, because of the previous problem, you realize you cannot have a square root on the bottom. Okay, so try to follow along here. We're slow. Stop the video if you need to, and rewind. We are going to multiply this whole thing by its conjugate. And the conjugate is the same exact binomial, except it's going to be the opposite sign here in the middle. So it's going to be 2 plus the square root of 3 over 2 plus the square root of 3. Okay, now what you have to recall here is that this problem is just a dots problem, a difference of two squares. So remember we had problems like this in the previous chapter, right? So when we multiplied it, we squared the first, we squared the last, and the sign in between is always a subtraction sign. Okay, so we're going to take this same concept that you learned previously and we're going to apply it here to this. Okay, that's a monomial. So when we multiply it, we're just going to multiply it out, distribute it. So 7 times 2 is 14, plus 7's a whole number, so keep it on the outside, 7 times the square root of 3, over. Okay, here's where this is going to get complicated. So I'm going to do it the long way, and then I'm going to also show you the short way. So the long way is, I'll put it here on the side, 2 minus the square root of 3 times 2 plus the square root of 3. Okay, first, 2 times 2 is 4. 2 times square root of 3 is plus 2 square root of 3. Negative 3 times 2 is going to be negative 2 square root of 3. And then negative square root of 3 times negative square root of 3 is going to be negative square root of 9. Okay, now we're going to simplify this. It's going to be 4, and if you notice, 2 square root of 3 minus 2 square root of 3, those two cancel out. So it's going to be 4 minus the square root of 9, which is 3, and the answer is going to be 1. Okay, so that's showing all my steps. So now let's do it this way up here, where we square the first. So we're going to square the first term, which is 4. We're going to square the last term. So square root of 3 times square root of 3 is square root of 9. And the sign in between is always going to be a subtraction sign. Okay, and then again, we'll continue to simplify that. It's going to be 4 minus 3, which is going to equal 1. So with the fraction, you don't need to have a 1 there. So here is my final answer.